On problem 18, it wants you to graph the function that it gives you, showing at least 2 cycles or 2 of its periods, and then use the graph to determine its domain and range. So, I mean, you could, of course, just put that into your calculator and see what it looks like. However, I'm actually going to graph it. So let's recall that sine of wx, that's what the actual form is, and we can use w, which in this case is 4, to figure out our period. Period, which is denoted as t, can be found for sine and cosine with the following formula: 2 pi over w. So for this function, our period is 2 pi over 4, which reduces to pi over 2. Okay, so knowing that, I can draw my graph going from negative pi over 2 to pi over 2, because I know it's centered about the y-axis. Okay, so now the max that sine will be is positive 1, and the lowest that it will be is negative 1, because we don't have any other transformation shifts. So sine comes out of the origin, goes down about midway between its period, and touches like that. On this side, sine will come down and then up. So that's what sine would look like. Say it was a cosine. If it was a cosine, then it would basically have the same period. It's just that instead of being at 0, 0, it would be at 1, because cos looks like this for its period. Now that we have the graph drawn, let's figure out our domain. Well, for sine and even cosine, the domain is pretty much all real numbers. There are no restrictions, so it's negative infinity to positive infinity. What about the range? Well, since the period is the only thing that changed, it wasn't like stretched or compressed any, the range is the same as the original function, which goes from 1, and it touches 1, to negative 1. So our range is square bracket negative 1 to 1.